Hello and welcome to Ms. Impano's flipped class. We're on notes 1.8. This is multiplying fractions and mixed numbers. We've talked about reducing and simplifying along with equivalent fractions. We're also taking a look and we will be using the information that we've done previously for multiplying integers as well. So let's take a look at our note sheet and let's add our name and date to this. And we're in the Unit 1 Pre-Algebra Review. The section title again is 1.8 Multiplying Fractions and Mixed Numbers. And the pages that would associate with this, we have pizzazz pages in the fractions section, which are at the very end after the bright orange page that says fractions, to take a look at those. And that's page 36 through 39 for those multiplying fractions and mixed numbers examples and practice sets. So vocabulary we're going to take a look at is factor. The first, we have factor as well as we have cross cancel for our two vocabulary words we're taking a look at. So factor, the factors are what you multiply to get a number or an expression. And in an example here we have 2 times 3 equals 6. And in this example, we're taking a look at the 2 and the 3 are the factors, and the 6 is the products. Okay, that's the result that we're taking a look at. Also, let's take a look at the cross cancel for a vocabulary word. So cross cancel is a way to reduce fractions before you multiply by canceling common factors on the top, which is the numerator, and the bottom, which is the denominator. Next, we're going to take a look at some key concepts about multiplying fractions and mixed numbers together using these words. So using factor as well as cross cancel. So for our first step under these key concepts, and again we're right here, we're going to turn all whole or mixed numbers into fractions. So we're going to convert them. The next thing we're going to do is to reduce if possible, and look to cross-cancel common factors on the top and the bottom. The third thing is to multiply straight across by reducing the whole number if possible. So if we end up with a fraction as we multiply across, and we end up with a fraction that might look like 15 divided by 10, let's make that a little nicer. Let's see if we can make this neater. So if we had a fraction of 15 over 10, we can always reduce this. Both of these have an option, they're factors of 5. So 3 5s can go into this, and 2 5s can go into this. So we would get a fraction then of 3 halves, which can be converted into a mixed number of 1 and 1/2. Now, in this case, we couldn't convert and reduce it all the way down to a whole number, but if we had something like 30 over 10, we can reduce this into a completely whole number, and this does reduce by 10 on each and give us 3 as our whole number. So just organizing that to say, if we can, reducing it all the way down. Now, taking a look, the next thing is to apply Mr. Livesey's rule of thumb, and Mr. Livesey is our math department chair. If you haven't met him, I'm sure you will meet him at some point in the future. And take a look, his rule of thumb for multiplying fractions and mixed numbers is that if it begins with all fractions, then it can end as a fraction. If it began with mixed numbers or whole numbers, you're going to want to change it into a mixed number or a whole number if that makes sense at the end. So let's go ahead and take a look at a few examples. We'll have 4 examples that you will see completely done out and 3 to try on your own. Now, taking a look at these examples, let's take a look at our first example of negative 4 over 15 multiplied by the whole number of 9. Now we're going to make and go ahead and change 9 into a fraction. So we can do that by taking negative 4 over 15 and multiplying by 9 over 1. because dividing a whole number by 1 is going to convert it into a fraction. Now we can go ahead and say if there is any possible way to reduce or cross-cancel among these two fractions. And in fact, I can cross-cancel because 15 and 9 both have a common factor of 3. So if I go ahead and do this, there are 3 3s in 9 and 5 3s in 15. Now I'm going to multiply straight across and go ahead and take -4 times 3 and divide that by 5 times 1. Once I do that, I get -12 divided by 5, which in this case, because I did have both a fraction multiplied by a whole number, I'm going to see if I can turn this result of -12 over 5 into a mixed number. Now, I know that my mixed number is going to be negative, and I'm going to ask myself, does 5 have an opportunity to go into 12 evenly? And in fact, it does 2 separate times. So I'm going to have a mixed number of -2 with a remainder of 2 and over 5. So -2 and 2/5 is that answer. Let's take a look at another multiplication situation where we have a -1 over 1/14 multiplied by -7 over 10. Again, I'm multiplying a mixed number times a fraction. And here, using our integer rules, I have 2 negatives, so I know that my answer when I have the result should give me a positive answer, whether or not it's a fraction, whole number, or mixed number. So that's always good to remind ourselves about. Now before I go ahead and multiply this, I need to make and convert this mixed number into a fraction. So I'm going to go ahead and ignore the negative and multiply the 14 times the 1 and add 1 more to that, giving myself -15 over 14 times -7 over 10. Now I've got two fractions multiplied together, and I can go ahead and take a look and see if I can reduce if possible. So I know I can cross cancel, so this 14 and the -7 have an opportunity to cancel. So I am going to do that. And in the 14 and the -7, I have a common factor of 7. So for 14, there are 2 7s involved. And for -7, there's a -1 of those involved. I also take a look and I have a -15 and 10. The -15 is on the top and the 10 is in the denominator, so I can go ahead and cross cancel those as well. -15 and 10 both have a 5 in common, so I'm going to head to cancel those out and get a -3 for that 15 and a +2 for the 10. Again, I kept the sign with whatever I was canceling to make that easiest for myself, and I'm going to go ahead and multiply straight across. So that means I'm going to multiply -3 times -1 and divide that by 2 times 2. This is going to give me a positive answer of 3 over 4. And 3 over 4 is already reduced as much as it can possibly be, so I can leave this as a fraction. It's kind of a nice piece. So let's go ahead and take a look at a couple more examples. So here on the back side, we're not going to have any more vocabulary or key concepts, so you can shift your eyes all the way down to the examples. So our first example on the back that we're going to work with is 16 divided by 5, multiplied by -3 divided by 8, multiplied again by 4 over 9. Okay, now here we have 3 different fractions. The first fraction actually, if you'll notice, is an improper fraction because it has the numerator as its larger number, which is nice because that means we didn't have to go through the pain of converting it from the mixed number into that improper fraction. So taking a look at this, we're going to organize and do some reduction / cross-canceling. We're first going to take a look at what we can do with fractions that are next to each other, And if there's nothing that we can do with fractions that are next to each other, we can go ahead and look from the first to the third fraction. So let's see what we can do. We notice that the 16 and 8 have something in common. They both have 8 in common. And so we're going to have a 2 for where the 16 was and a 1 where the 8 was. And we also take a look, and the -3 and the 9 can be canceled as well and provide ourselves with the option of a -1 and a +3. Those are circled in blue. Now remember that the original piece we were dealing with for this fraction, I'm going to highlight it right here, was a -3, and so in fact we do have a -1 for the factor that remains. Going ahead and taking a look, I'm noticing that I don't have anything else that can cancel. The 4 and the 5, so the 4 in the numerator and the 5 in the denominator, don't have a common factor, and none of the other situations that we've already reduced have other opportunities for us to reduce any further. So we're going to take a look then and multiply straight across and take 2 times -1 times 4 and divide that by 5 times 1 times 3. So now that we have multiplied those straight across, we end up with a -8 over 15, and that is in fact our most reduced answer. We don't have to convert that into a mixed number because it is not an improper fraction. It also doesn't convert evenly into a whole number, so this is our final answer of -8 over 15. We have one more to discuss as a whole group, and then you can try some on your own. The last problem to discuss on as a whole group is -7 over 10 times -15 over 21 times -10 over 7. Now there's a couple of ways to do this problem, as you might notice. So the first thing that I'm going to ask you to look for is if any of the fractions that you're multiplying are direct reciprocals. So in this case, the -7 over 10 and the -10 over 7 are in fact reciprocals. And when we multiply reciprocals, as we noticed in a previous example, when we multiply reciprocals, we actually get an answer of 1. So that would then reduce immediately to -15 over 21. And we can reduce that by 3 on each of those. So if I divide the numerator and denominator by 3, I can reduce that fraction to take a look and make it a -5 over 7. Now there's another way if you don't immediately notice any reciprocal. So if we don't notice that -7 over 10 is the same thing as -10 over 7, let's take a look at what we would do then. We probably would go ahead and just try and cancel what we see. So that would then look like taking the -7 and the 21 in the first two fractions and reducing those. So this is just a reminder, so if you don't notice immediately, you can look to cross cancel. So the -7 becomes a -1 and the 21 becomes a 3. Next I'm going to take a look and see what other item I might be able to cross cancel. And I notice that the 10 and the -15 have a 5 in common. So I'm going to cross the 10 out and write a 2, and the -15 and write -3. Similarly, I'm going to say, hey, I can even reduce this even further. I also notice that the -10 on the top, which is over here, and this 2, which I've already reduced down to a 2, can also be simplified and cross-canceled. So there is 1, 2, and 2. And there are -5 2's in -10. So if I take a look at this then, I'm going to be able to reduce these even further. And I'm going to back up a step, because what that would look like And I just made that play a little fast. So what that would look like then is I can notice that this will become, let's see what color I'm using. Let's use a dark color. So this would become a 1, and this would become a -5. All right. And then the next thing that I get to notice is that over here, and I'm going to use a different highlighter color, if you don't mind, one moment. Let's use a blue. I have a -3 divided by a +3, which reduces to a -1 as well. And I can go ahead and make that cancellation now. So if I go ahead and make that cancellation now, then I can take a look and say, well, hey, I'm just multiplying straight across a -1 times a -1 times a -5, and in the denominator, I'm multiplying a 1 times 7. Now, that's really good because I can just jump ahead and make this -5/7. So let's double check at what that might look like. And in fact, I do get the same thing of -5/7. So let's take a look at the 3 problems we are going to be trying on your own for this wonderful situation. And here they are. So the first try on your own problem is, in fact, -13/20 multiplied by -1 and 1/26. So we have a fraction multiplied by a mixed number, and both are negative. So be sure to use your integer rules with multiplication in order to make sure that the positive and negative result, or your solution, is consistent with those rules. So same sign, you'll get a positive answer. Different sign, you'll get a negative answer when you have 2 of them. So let's take a look then. The next try on your own example is going to be a mixed number times a fraction, and you're going to be multiplying 7 1/3 times -10/11. And the third try on your own example is going to be a whole number multiplied by a fraction. So -3 multiplied by 2/9. Now that you have taken a look at the notes, please be sure to look back at examples, ask questions. The 3 try on your own examples you will have in class, so we will go over them. You get full credit if you make an attempt on these try on your own examples. They do not need to be correct in order for you to get full credit for these notes, but an attempt is required. Thank you very much for your time, and we'll talk to you in class.